Okay, right now I'm joined by Dr. Muyiwa Akintoye. He's the Chief Product Officer of Planetary. Muyiwa has been at the forefront of developing mycoprotein-based foods that don't just deliver on sustainability, but also on taste and texture, the things consumers really care about when deciding whether or not to make these proteins part of their diet. It's great to have you with us.
Oh, thank you. It's good to be here.
Now, to kick things off, could you give us a quick outline of your role as Chief Product Officer at Planetary and how considerations like flavour and texture shape your priorities in product development?
Okay, that's absolutely fine. So I look after anything related to product at Planetary, and there's two parts to that. The first part is the actual microprotein that we make. So we need to ensure that the microprotein meets the spec, both for our customers, but more importantly, for the consumers of the product. So Planetary is currently set up as a B2B player. So our intention is to make products or microprotein, what I would call raw microprotein, that other companies can then convert to food. So I hasten to add, as many people will know, that microprotein itself is not food. It's just a raw material that enables us to create food. So all the attributes of the raw microprotein need to deliver in terms of ensuring that the food quality that the consumers ultimately get is top-notch. So my role is to ensure that we deliver that raw microprotein to the highest spec possible. But I also have considerable experience in actual product development, food development, and have spent many years tinkering around with microprotein. Microprotein of itself is a key ingredient, but it only works when you combine it with other things, binders, flavors, and some other raw materials that then bring the microprotein to life as a dish or a food that customers get. So both of those go hand in hand. The other bit that I would add is the process of converting microprotein into food is also critical. You can't really divorce it from the raw materials that you put together. So both the raw materials and the processing steps that are involved help to create high quality microprotein based food products.
Mm-hmm.
And
now, when we
throughout
look
this discussion, I was going to say I will distinguish between raw microprotein and microprotein based foods.
Right. Now, when we look at consumer adoption, nutrition is important, but ultimately people buy with their taste buds. So from your perspective, what are the biggest consumer-driven challenges in making microproteins, not just nutritious, but also delicious and texturally appealing?
The key thing to think about is how the microprotein actually grows. Now, as an organism that grows, it basically consumes sugar, or carbohydrate, I should say, to use a better term. And then as it consumes this carbohydrate, it grows and produces what we call biomass. So it's the actual organism itself that becomes the microprotein. Like everything in life, you are what you eat. So the microprotein or the fungus that produces the microprotein very much depends on what it's fed. So if you give it the right ingredients, then it will grow nicely and give you relatively innocuous taste. If you feed it with raw materials that have a specific characteristic, the fungus will imbibe that, and that will be implicated in the final product. So at Planetary, as with many other microprotein producers, what we need to do is to ensure that we give it the right kind of materials that allow it to grow profusely without significantly imbibing off taste and off flavors from the environment in which it's growing. So we keep it simple, and I'm sure many other microprotein manufacturers will tell you the same. We give it a carbohydrate source, which is critical. We give it a nitrogen source. Without nitrogen, it cannot produce the protein. And we give it some minerals and vitamins like we all need. It's a living organism, and as long as you give it all the things it needs, it will grow pretty much as you expect it to. And it's a judicious selection of these ingredients, knowing what it needs to grow fast and knowing what it will imbibe that may impact on taste. It's a judicious selection of these ingredients that allow us to produce relatively bland microprotein that can be useful for consumer-facing products.
Mm-hmm. Now, microproteins, they naturally come with their own sensory profile, which can be a blessing, I guess, or a challenge, depending on the application. How do you decide whether to neutralize those inherent notes or lean into them, for example, to enhance umami depth?
Yes, with the umami or savory type products, microprotein actually lends itself very well to that. Its natural kind of taste is savory, as you've rightly mentioned. So you have a base savory umami taste. If we get that right, which many people work to get it right, then it actually enhances the overall taste if you're making meat type products.
Mm-hmm.
So when you look at things like sausages, burgers, chicken style products, particularly the white meat type applications, good quality microprotein that has a light savory flavor actually lends itself very well into these kind of products, which means when you add flavoring systems to it, you don't have to go too far. Very clearly, you can just use seasonings. So typically salts, yeast extracts, and some basic seasonings like onion powder, garlic powder. Those kind of things enhance the natural savory character of the products. Of course, you can go one step further by actually working with flavor companies to develop seasonings specifically to move the product in a particular direction. And that works well too. You can enhance the natural tasting savory notes that are present in microprotein, particularly if it's been processed properly.
Now, off flavors, they're often a sticking point when it comes to microbial proteins. From your experience, what strategies, whether that's strain selection or fermentation control or even DSP, have proven most effective at mitigating those unwanted notes?
There's a number of things. Obviously, if the fermentation process is abused or not strictly controlled, yes, the organism will pick up off notes or create its own off notes in trying to survive, as it were. So we have what we call within Planetary our BioBlocks technology, which obviously I won't go into great detail about, which enables us to profile the fermentation system, and that includes media selection and components of the media. Strain selection, you are right, is also important. I mean, it's no secret that at the moment, Planetary is using Fusarium venenatum, which is a kind of standard strain in the industry. But we are also, as a company, working on other strains in the background that have different physical and chemical characteristics to Fusarium. And of course, as we learn more and more about these other strains, we can tailor the physical characteristics, and that's both flavor and texture, to the directions that we want. Having said that, you can also control it by how you select your media. So we have a lot of scientists in the background are beavering away, working on media formulation, which also allows us to move the products, both texture and flavor, in the specific directions that we want. So for instance, we can talk about things like longer hyphae, different colored material that's a little bit more pasty, material that's a little bit shorter in texture. Those kind of things can be achieved by what we call our BioBlocks technology, which is well known within the Planetary system. So that's kind of what we do. It's just moving things in a different direction. I always compare it to a chef who's working in the kitchen, and they can modify their recipe to move things in certain directions. I mean, the very simple ways of doing it are: what spices do you use in the kitchen? What amount of salt do you use? Do you add chili? Do you add black pepper? It's those kind of simple things. Not that we will use that, of course, in the fermentation. I'm just using that as an analogy to show that just as chefs can move flavors and textures in different directions by selection of ingredients and process conditions, cooking, baking, steaming, we do the same pretty much. Obviously at an industrial scale, not
in your kitchen.
Not
Now, clean label expectations, they make this even trickier. So consumers don't want to see things like masking agents or additives. So how do you strike that balance between technical reality at scale and the demand for simpler, more natural solutions?
Yeah, it's always a balance, really. It's kind of a tricky balance because, yes, sometimes you may need to use masking agents. And, on a personal note, I don't have a problem with masking agents. Some of them can be natural. And most definitely safe. No company will knowingly use an unsafe ingredient. So all of these things would have been tested. So I personally don't have a problem with masking agents. I know some consumers do, but you can have these natural components built into a flavor system, whereby if you're using added flavors, you can kind of knock out or some of these rough edges. Now, again, think about a chef in the kitchen who has an ingredient or a product that they want to make. In order to make it tasty, they will use added ingredients, as I said, salt, pepper, spices. It's pretty much the same within what Planetary do. So yes, we may use some added flavors in our finished products, but in our raw mycoprotein, there is no flavor there and there are no masking agents. And by judicious use and selection of our media, we can create very bland tasting mycoprotein where inherently we don't need masking agents.
Mm-hmm. It feels like every category has had to wrestle with various challenges in some way, from plant proteins to dairy alternatives. Are there particular learnings from those spaces that have shaped your approach to flavor optimization in mycoproteins?
Well, yes, there are. As I said earlier on, mycoprotein has its own natural flavoring system, which works generally very well with meat type applications. But of course, mycoprotein does not need to be limited to savory applications. There are a number of developments already in the market and still in development within many countries, moving away from just meat. So looking at things on the dairy side, for instance, cheese, milk, yogurts, those sort of things are a completely different ballgame to what you would do with savory. So how do you move a naturally savory tasting product into these kind of what I would call more bland or sweet applications? Yes, there are some downstream processes that need to be applied to the mycoprotein biomass that will enable you to make it bland. And it involves using physical processes to try and reduce, sometimes maybe even completely eliminate these savory notes. Having said that, maybe I'll retract a bit. You probably can't completely eliminate it, but you can reduce them to a level where they are so low as to be imperceptible. Mm-hmm. And of course, when you look at the kind of applications that I've just talked about there in dairy, there's a lot of water and acids involved in those products naturally. And these kind of acids, especially the natural acids that form, have a very good and important role in reducing, sometimes even eliminating these savory notes, so that you get a very bland, natural tasting dairy type application.
Now, if flavor is half the equation, texture arguably is the other half. Consumers, they want that fibrousness or bite that they associate with animal proteins. So how do you go about engineering mycoprotein textures to replicate those qualities?
Yes. So think about the mycoprotein basically as a fiber, a physical fiber. Under the microscope, it actually looks like jumbled up spaghetti. So what we and many other companies do, of course, is try and align those fibers so that you get the meaty characteristic. So two things come into play here. One is, how do we grow the mycoprotein so we can get these long fibers? And it's always going to be a balance between how long the fibers are and how fast you can grow the mycoprotein. And they tend to be inversely correlated to each other. So usually the rule of thumb is that the faster the mycoprotein grows, which gives you better yield, generally the shorter the fibers are. So depending on what the application is that we want it to be, we can control to a reasonable degree the fiber length of the mycoprotein that we make. So that gives us a good head start in how we get these fibers. The second thing to do is then to find a way to align those fibers such that you get these thick bundles of a mate-like structure. And that is, of course, where the downstream processing and recipe formulation comes in. So by use of binders and other food ingredients like starches, like textured vegetable protein of different types, or the addition of certain chemicals will make the mycoprotein kind of bind to itself. And the more you can create these thicker bundles, the closer the product is to meat. Of course, the trick is to try and do this in a natural way without 1 million ingredients in your recipe. And also looking at the different types of downstream technology that allow you to convert a pasty mycoprotein into a fibrous structure. And there are different ways of doing that.
There's a lot of focus on mycoproteins as a meat analog ingredient, but they obviously have potential beyond that. Do you see applications in other niches like seafood or dairy or even bakery?
Yes, certainly. Over the years, I've actually been fortunate enough to be involved in many of these applications. Obviously, very few of them have actually hit the market. But yes, is a simple answer to your question. By looking at what I described earlier on, different fiber lengths, different fiber structure, and further downstream processes, yes, you can look into things like creating dry powders, for instance, or powders. Most powders are dry. You can look into creating powders that then can be used in other applications. So in my role, not just within Planetary, but in previous jobs working with mycoprotein, we've looked at a whole range of things. So snacks, expanded snacks, breakfast cereals, pasta, soups, bread, cakes, all those sorts of things are things that you can certainly apply mycoprotein to. The challenge, of course, is how do you get the mycoprotein in there without bringing the savory taste? Because, of course, as you concentrate the mycoprotein, you also concentrate the taste. So there is still a gap between where you would like to be in terms of how much mycoprotein you can physically put into these type of products and how you actually get there. The other thing to point out is with a number of these kind of products, because mycoprotein itself doesn't necessarily have the functionality of some of the kind of things that we've just talked about, there is a natural limit as to how much mycoprotein you can add into these ingredients, particularly if you're looking at it from a protein fortification point of view. And I'll give you a very good example, which hopefully many of your listeners will understand. If you look at bread, the key active ingredient in bread is wheat gluten. And the stronger the gluten, generally, the stronger the bread. Mycoprotein, of course, in these kind of bakery applications can be used, but mycoprotein is not gluten. It will not replace gluten. So if you're going to put mycoprotein into bread as an example, or a cake as another example, then we have to kind of walk along with the wheat gluten in order to achieve that. So that's just one example. But if you look at across the range of all the other products that I just mentioned, you would find similar challenges, sometimes limitations in that area, but they can be done.
Yeah. And when you think of mycoproteins as an ingredient platform rather than just a single product, what kinds of new applications or product formats excite you the most right now?
I would say we are doing quite a lot of work in the dairy side of things. It's always been the case that if you want a very good cheese product, for example, or a yogurt, most of the time you start with milk. Of course, with soy, which is the other key ingredient that goes into a lot of these kind of non-milk. I'm sort of trying not to say vegan, but maybe vegan is the right word to use here. You invariably have to use things like soy or pea. They come with their own challenges. They carry a much higher carbon footprint than mycoprotein does. And of course, there is a taste issue in trying to extract this protein. The good thing with mycoprotein in this area is that you don't actually have to physically extract the protein from the mycoprotein in order to get a good product. You can use the whole product. And of course, it comes with fiber, which a lot of the protein isolates, in fact, none of the protein isolates can deliver fiber. You have to add the fiber as an extra if you want a high fiber product. With mycoprotein, you can do that. And that's one of the things that excites me. So thinking about the kind of applications where you typically will not find high protein and high fiber together unless you assemble it, you can do that with mycoprotein just by itself, as long as you get the right process conditions to do that. And I find that quite exciting because the sky's the limit in terms of what you can do in that area. We're only limited by the processes that we haven't yet developed or fully understood. It's a wide scope there for bringing those things together. And so that gives me particular interest. And it's an area that I'm working on.
Now, looking ahead, if you had to imagine the holy grail, shall we say, of mycoprotein sensory experience in, say, 5 years' time, what would that look like, and how close do you think we are to getting there?
The big challenge that we still face, I would say, is trying to get mycoprotein to a higher protein content. Mycoprotein naturally only has about between 11 and 13% in its natural state as a wet ingredient. Of course, when you take the water out and dewater it by drying, we can get to about 40 to 50% protein. I'd kind of like to see either strains that are able to produce more protein per gram, or that we can engineer the strains in a natural way to encourage them or make them produce even more protein. Because what that would do is it will bring the cost down per unit of protein. And of course, for me, that's an area, particularly in other countries or other parts of the world where protein consumption still remains an issue, that we can get relatively inexpensive protein by using typical fermentation methods. Most fungi, particularly Fusarium, grows very fast if you give it the right conditions. So if we can make it produce even more protein per unit kilogram of media, for me, that would be a great place to be. And I think in 5 years' time, hopefully before that, we will start to see a move in that direction. The other thing I would say is the infrastructure for making mycoprotein currently is very high, it's very high. You need scale in order to be able to make mycoprotein more efficiently. I would like to see, and I think we will get there in, I would say, 5 to 10 years' time, where you don't need such heavy infrastructure to make mycoprotein, and it can be made relatively cheaply with very little capital. That would be a great place to be. And I know there's a number of technologies that are being redefined and redeveloped to get fermentation to be even more cost effective.
Well, we're seeing exciting progress in areas like strain engineering, which you talked about, and precision fermentation. Is there any way that you see those advances complementing biomass mycoproteins in terms of delivering even better flavor or texture?
I do. Obviously, in Europe, precision fermentation is still a challenge from a regulatory point of view. But yes, I see it as only good things. Obviously, all the protections need to be in place, that we don't create what is perceived or stated as Frankenstein foods or Frankenstein products. That's not what it's about. But with judicious use of the technology that currently is available, I see that as only a good thing. And when you look in the pharma side of precision fermentation, it's already having great benefits. Insulin is probably the biggest example of that. Production is now done mostly by precision fermentation. And, there's no reason why that industry or that technology can't be advanced even further. I think it's just a matter of time.
Now, few people, I would imagine, in the world have been working with mycoproteins for as long as you have. If you had to distill it down to one key insight, the single most important lesson you've learned about mycoproteins truly consumer ready, what would that be?
I would say don't underestimate the customer. I've made this mistake a number of times where we have developed products that I just kept saying, oh, no, they're not good enough. They're not good enough. And we just keep working at it and working at it. And I remember one of my previous bosses used to say to me that good is the enemy of bad, as it were. So sometimes you just have to go with what's good enough. And I found that to be the case where we have eventually launched products, and I've been completely blown away by the reception to those products, because customers are basically gagging for these kind of products. And in trying to make them as good as we possibly can, which is a good place to be, sometimes we just go too far. So for me, the biggest insight in this area is thinking of what your customers need. Maybe they're not quite as sophisticated as us product developers in terms of what we think the customer wants. The customer actually knows what they want, and they know when they get it that if it appeals to them, they will go with it. So sometimes we probably just need to stop at a certain point, do our consumer checks, of course, that's critical, but ensure that we're not trying to push a Rolls Royce to the customers when actually what they want is a BMW. Something like that. I hope that analogy works.
It works for me. Look, Muyiwa, thank you very much for joining me today. It's been great to hear how you're approaching the sensory side of mycoproteins and how Planetary is working to make these ingredients not only sustainable, but genuinely enjoyable for consumers. Really appreciate your time today. Thank you.
Thank you very much. Thanks for having me.